Hi, this lesson is about the attributes of the graphs of the sine function and the cosine function. Both of these functions share some of the same characteristics. The first one is that they both have a period of 2 pi. A period is how long it takes to go through one cycle of the graph, and a cycle will look like a wave. The sine function is the one that you see here in red. The cosine function is the one below in blue. The amplitude is equal to 1 for both sine and cosine. The domain for both functions is all real numbers. And typically, our domain will be stated in radians. Our angles will be stated in radians. As you can see on the horizontal axis, I have my radian measure laid out for both graphs. And your range, which are the y values, are from -1 to 1 because those will be the minimum and the maximum values that these graphs will take on. In order to graph these, it is helpful to remember the unit circle that's here on the right. Remember the points on the quadrantal angles. At 0 and at 2 pi, the point is 1, 0. At pi over 2, the point is 0, 1. At pi, the terminal point is -1, 0. And at 3 pi over 2, the terminal point is 0, -1. Remember that the x-coordinates of the point are the cosine values, and the y-coordinates of the point are the sine values. So here, when I'm at 0 degrees, my sine value is 0. So I plot 0, 0. Then when I'm at pi over 2, the y value is 1. So at pi over 2, I plot the point pi over 2, 1. At pi, the sine value is 0. So I'm back to the horizontal axis. And at 3 pi over 2, the y value is -1. So I have my other point. And then the last point in the period is back at 2 pi, which returns us to a value of 0. So there is your point. So if you plot those 5 points that I plotted in green and connect them in this wave fashion, so it shouldn't be a jagged lines like this. It should be a smooth curve. And there you have your sine function. All the other values that we're already familiar with for sine also exist on this graph. For example, we know that pi over 6, which is, around here, has a value of a half. And so that looks like it's about a half on the graph because pi over 6 is 30 degrees and the sine of 30 degrees is 1 over 2. And all the other values in between 0 and 2 pi are represented on this curve. So we can use the unit circle again to help us plot cosine. And cosine is here in blue. So remember, at 0 degrees, the x value of the terminal point is 1. So I start at 0, 1. And then at pi over 2, the cosine value is 0. So now I'm on the horizontal axis. At pi, the cosine value is -1. So that's that third point there. At 3 pi over 2, the cosine value is 0. And at 2 pi, the cosine value is 1. So again, connecting those 5 points in green from left to right in this smooth curve, you'll have your cosine function. The sine and the cosine function they look almost exactly the same, except they are shifted over by pi over 2 units. So in other words, if I could shift this point over to the left by pi over 2 units, it would look exactly the same as the cosine function below. And same thing here, if I were to shift this over, I would be, in the other direction. If I was shifting in the other direction, my cosine function would look like my sine function. So it is helpful to know that unit circle well to help you remember how to draw these graphs. The amplitude of sine and cosine is 1, but that amplitude will change when sine or cosine have a leading coefficient that I'm going to call A. When you have a number other than 1 there, that number will be stated, or if it has a negative in front, that would imply -1. And the amplitude will always be the absolute value of whatever that number is. So amplitude is always positive. It will be the absolute value of A. And the period can also change. Remember, typically the period is 2 pi units. It takes 2 pi units to go through one wave of the sine or cosine function, the same way as it takes 2 pi units to go around the unit circle once. But the period can change if you have a coefficient in front of the angle. So, and we're going to call that coefficient B. So here, if I have y equals a sine of b theta and y equals a cosine of b theta, that b being multiplied by the angle theta will affect your period. And the way that period is computed is that you would say that the period p is equal to 2 pi divided by b. So it is possible for the period to get shorter than 2 pi units or longer than 2 pi units, depending on what the value of b is. So let's practice. If I have a function like the one below, we're going to identify the amplitude and the period, and then we'll sketch one period of this graph. So we have y equals 3 sine of 2x. So according to what I stated here, that means that the a is 3 and the b is 2. So notice that here I called my angle x instead of theta, but that's fine. That's your independent variable, y is your dependent variable. So I'm going to plug it into these formulas. So I know amplitude is the absolute value of A. Absolute value of 3 is 3. And the period is 2 pi over B. So that's 2 pi over 2. So I have a period of pi units. That means it is a shorter period than what the original sine function would normally be. It normally takes 2 pi units to go through one wave or one cycle. But in this case, we're going to go through one wave or one cycle in only pi units. And that amplitude is also going to change how high up and how far down we go in that oscillating motion. So you want to draw the beginning and the end of your period, which is from 0 to pi on the x-axis, and then break up from 0 to pi into 4 pieces. So the middle is pi over 2, and the middle of 0 and pi over 2 is pi over 4, and then the other quarter on the other half of this, between pi over 2 and pi, is 3 pi over 4. So the way you compute that is that you would take the middle one and the last value, add them and divide it by 2. You're basically finding where's the middle, where's the midpoint, what is the average of those two numbers. So you add them and divide by 2. So in order to add pi over 2 and pi is 2 pi over 2. So this becomes 3 pi over 2 divided by 2, which means 3 pi over 2 times a half. Remember, change division to multiplication and take the reciprocal of the second one. And then that gives you 3 pi over 4, which is that third quarter there. Then we can plot the points. So the original sine function starts at 0, so this one must also start at 0. And then the sine function goes up, and normally it goes up to 1. But this time, because we're multiplying by 3 and my amplitude is 3, you will go up to 3. Then you return back to 0. Then you go down to -3, and then you return back to 0. So the shape is exactly the same as just sine of x, but the period is shorter and the maximum and minimum values changed from -1 to 1 to -3 and +3. So that means your domain is still all real numbers, but your range is from -3 to 3. Okay, so let's do another problem using our cosine function. And again, amplitude and period will be impacted because of the values that are given. So I have y is equal to -2 cosine of 1/2 x. So this is the first time we're seeing a negative number um, in our function, and -2 is the leading coefficient of that cosine function. So remember, the amplitude is the absolute value of this coefficient. So amplitude is 2, and the period is 2 pi divided by this number, which is a half. And 2 pi divided by a half is the same as 2 pi times 2, which means that your period is 4 pi units. So remember, the original cosine function has a period of 2 pi units. So now by multiplying the angle x by a half, it's actually going to make your period longer. It's going to take 4 pi units to go through one wave. We need to draw from 0 to 4 pi and then break up that section into 4 pieces. So the middle is 2 pi, and the middle of 0 and 2 pi is pi. And the third quarter here, the middle of 2 pi and 4 pi is 3 pi. So that one was a little bit easier to compute because they're whole numbers in front of the value of pi. So now I need to draw my cosine function. Now let me draw quickly what cosine looks like. So the regular cosine function goes from 0 to 2 pi, and then we have pi over 2 and pi and so forth. So at 0, it's at 1, and then it goes down to 0 here, and then at pi, it's at -1. Then it returns back to the x-axis, and then it ends at 1. So the cosine function looks like this. Okay, and so typically when we draw it for this graph, it should have the same shape, but this negative in front means that it's going to be a reflection across the x-axis, meaning the whole thing is going to flip. So instead of starting at 1 here, it's actually going to start at 0, -2. And then it goes to the x-axis, and then it goes up to +2. So we're here, and then back down to 0, and it ends at -2, 4 pi -2. It should always end at the same value of y as where the period started. Okay. So it is possible for these functions to also be impacted by something called a phase shift or a displacement. A phase shift is going to refer to a horizontal shift in the graph. So instead of starting at an angle of 0, it could start either to the left of the of 0 or to the right. Um, so the shapes again will be the same. We'll have these wave shapes, but it will start either in the to the left of the y-axis or to the right. And the general format of those functions will be y equals a times sine b theta plus c. So that plus c is something new. Or y is equal to a cosine of b theta plus c. So the plus c impacts the graph horizontally. It's going to shift it either right or left. And there are, again, our formulas. The amplitude will be the absolute value of a, and a is the leading coefficient. The period will be 2 pi divided by b, where the b is the number in front of the variable, the independent variable. I called it theta in this box, but they could be called x. or any other variable, but theta or x would be the more common ones. And then the c, we use that c to compute the displacement. And remember, displacement is going to be a phase shift, a horizontal shift left or right. And that calculation of how to compute that phase shift or the displacement will be negative c divided by b. And again, that'll be the opposite sign of whatever that value is divided by the coefficient in front of the variable. Once you compute that, then in order to sketch it, you're going to need to know, well, where does the graph start and where does one period of the graph start and where does one period end? And so it will always start wherever your phase shift was. So that computation, negative c over b, is where the graph starts. And then it's going to end when you add the period to that phase shift. So remember, the period is 2 pi over b. You add that value to the negative c over b, and that will give you the end of the period. If you know the beginning and end, then you'll be able to sketch the entire wave. So let's practice. Here I want to identify the amplitude, the period, and the displacement for y equals sine pi theta plus 4 pi. So first thing we want to do is identify the a, b, and c. A is the coefficient of sine, which is 1. B is the coefficient of the angle theta, which is pi. And c is the number that's being added to pi theta, which is 4 pi. Then I just have to plug it into the formulas. The amplitude will be the absolute value of A, so the amplitude is 1. The period is 2 pi divided by B. 2 pi divided by pi, that's the value of B, is equal to 2. And then the displacement is negative c over B. So that will be negative 4 pi over pi. And when you simplify that, you get an answer of negative 4. That means that the start of the graph is at negative 4 and the end of the graph is 2 units after. So if you add negative 4 plus 2, it ends at negative 2. So the graph of sine for this particular function in example 3 is going to be in quadrants 2 and 3 because it's starting at negative 4 and it's ending at negative 2. So that's what you see here on the right in black. The start of the graph is at negative 4, the end is at negative 2, the middle is negative 3, and in between negative 4 and negative 3 is negative 3.5. And so the sine function typically looks like this from 0 to 2 pi. And so we should have the same shape. It's going between negative 1 and 1 on the y-axis, but it should be going up and then back to 0 and then down to negative 1, and it ends at 0 again, just like we did here, down and then up, back to 0, and down to negative 1, and then back at 2 pi. Okay, so we'll do one with cosine as well. We want to identify the amplitude, the period, and the displacement for y equals 3 cosine of 4x minus pi. So here, A is 3, B is 4, that's the coefficient in front of the variable x, and C is negative pi. So whatever sign's in front of it comes along with that value of C. So amplitude is the absolute value of A, so we get a value of 3. The period is 2 pi divided by B. So 2 pi divided by 4 gives me a period of pi over 2. So it takes pi over 2 units to go through one wave. And the displacement is negative c, but remember c is already negative, so it'll be negative pi divided by b, which is again 4. So the displacement is pi over 4. That is the start. Period starts at pi over 4 and it ends pi over 2 units later because the period is pi over 2. So pi over 4 plus pi over 2 means that the graph will end at 3 pi over 4 units. Okay, so I know it starts at pi over 2, ends at 3 pi over 4. That means my graph is going to be only in quadrants 1 and 4. Those are both positive values. So here's the beginning, pi over 4, and here's the end, 3 pi over 4. The middle of that is pi over 2. And again, the way you figure that out is you add the beginning and the end and divide by 2. It's like taking an average. And so the numerator is 4 pi over 4, which is just pi, and the denominator is 2. So that's why our middle is pi over 2. And then you would do the same thing to find 3 pi over 8 over here. You would add the pi over 4 and the pi over 2 and divide by 2, and that would give you 3 pi over 8 as the middle of that. Same thing here, add pi over 2 and 3 pi over 4 and divide by 2, and you would find that 5 pi over 8 is the other quarter. So cosine typically starts at 0, 1. Since our start is at pi over 4 and our amplitude is 3, we are starting at pi over 4, 3. Then it goes down to 3 pi over 8, 0. Then in the middle, it's at negative 3. Then it returns back to 0, and it should end at 3 pi over 4, 3. So cosine and sine should always begin and end at the same value of y when you're plotting one period of the graph. So that's it for this lesson. Give the homework a try.